After the Saturday that the Cascade Effect game was announced, we had a huge team meeting and everybody was there and we all sat down for 2 hours and we read the entire rulebook. We read every page twice, and all the important stuff we wrote up on the board, and we tagged those pages for future notice.
We really did get a jump start on our strategy by starting out with the game rules. This is the quickest way to become familiar with the game.
With the robot and the harvester, at first the design that was used was just one set of zip ties going straight up. It was eventually formed to a T where it had a set going out this way, and that way. In the end, Hoover vacuum design like this, almost random, worked the best, and that feeds the balls up into here and into there.
What I worked on was the other end of the arm, where we had the motor that was a lot faster than a servo. However, we used a motor encoder, which would make it just as accurate. I included all of the electrical components that were positioned in places so that motors, power leads, and servos could reach them efficiently. At our first competition, our strategy consisted of an autonomous that would drive off the ramp to score points, and then knock over the kickstand to score a reasonable amount of points during the autonomous phase. However, we could not knock the kickstand over by just running into it, which is where we eventually implemented this arm that would come around, grab the pole, and the robot would retract with the arm, which would pull the kickstand out and score us easy points.
We have 2 servos on the back and 1 on the front. To move rolling goals in order to score points by moving it up the ramp. The front servo is a special one because we have an arm which has just been prototyped that can put balls into the rolling goal. This feeds them up, drops it in.
Coming into our robotics team, we didn't really know much about Robot C. We knew about other programming languages, but not about C. And working with it has really helped us understand the basics of C and what we need to do to get the robot to do what we want it to do, really. Starting off with, we set up tank controls with joysticks on our controllers to control the 2 motors on our prototype robot, and we found that that worked relatively well, so we've stuck with that through to our current design. Through experimentation, we were able to come up with a formula, and we implemented that into a function recall system, so now we can simply type in the number of distance in inches we want the robot to move, and it'll move that number of inches. And we can type in the number of degrees that we want it to move, and they'll move that number of degrees.